This is a DIY air conditioner made with Peltiers. Peltier is an electronic component which heats its one side and cools the other when an electric current is applied to it. These are also called thermoelectric coolers. It functions thanks to the Peltier and Thomson effect. A question helped me build this box. The question was that if it was possible to build a homemade air conditioner using these Peltiers. As you may also tell, this device has two chambers, the cold chamber and the hot chamber. The hot side of the Peltiers is cooled with the computer cooling unit, so this makes up the hot chamber, because computer cooling units heats up as they try to cool the hot side of the Peltier, and the hot air created in the hot chamber escapes the chamber through the evacuation cone to the evacuation pipe. Meanwhile, the air in the cold chamber is circulated to the room by forcing them to these passive heat sinks in the cold chamber. Thus the cold air is supplied to the room and the hot air is sent away from the room. So these Peltier's main role is to ensure the temperature difference between the cold and the hot chamber. There are six fans on this machine now. Two of them circulate the cold air. Three fans, three fan is connected to the three active coolers on the hot side. They try to cool the hot chamber. And then there is the evacuation fan, which is connected to the evacuation pipe in order to evacuate the hot air. Let's now take a look at how I make this device. As you can see, I have collected all the parts needed for this device, including some active coolers, some passive coolers, some fans, and the peltiers. These parts were collected from some old computer cooling units, and these are the peltiers that I'm going to use. I'm not going to use all four of them, I'm going to use only three of them because I don't have space in the storage box that I'm going to use, and there's not a proper heatsink that I can find for this small peltier. As you can see here, I'm testing the peltiers. I'm going to use a storage box for the body. You can find these in any hardware store. And I will use some insulation material and the cover of a notebook for the heat barrier between the chambers. This barrier is pretty important. Here I'm changing the fan of one of the active coolers because it creates a lot of noise. And I will also change the heatsink under this fan because it obstructs the airflow. The reason I swapped this black fan with the red fan is that the black fan makes noise when it's face upwards. However, this one supplies a pretty good airflow and it doesn't make noise when it's face to side, so I will use it in this position. Here I am determining the position of the active coolers on the box so I can create the holes later. These coolers will create airflow from the outside to the inside of the hot chamber in order to cool the hot side of the Peltiers. This is a sink siphon, and I will use it as the evacuation pipe for my air conditioner. It will be great for this because it not only has a removable screw mount, it also has a structure that can be shaped or extended to any shape that I want. And of course, this pipe will have an insulation around it. As you can see, I have created the holes for the active coolers using my soldering iron. This actually damages the tip of the soldering iron. However, you can use an old soldering iron for this job because it's really great for melting plastic and creating holes in it. And the first active cooler didn't fit in the box, so I had to also make a hole in the side of the box in order to fit these three in a line. In order for the evacuation pipe to fit properly with the evacuation fan, I'm going to cut this piece from a 5-liter plastic water bottle. So I have created a conic surface between the evacuation fan and the evacuation pipe. Thus I can avoid the high pressure and so the air will not heat due to the friction forces that occur under high pressure. I wasn't able to use hot glue on this conic surface cut from the 5-liter water bottle because this plastic bottle piece deforms and shrinks when it's contacted with heat. So I used some duct tape to stick it on the box. It stops the air to escape at least. I need to cut some holes on the barrier between the hot and the cold chamber. Thermoelectric coolers will match these holes, so the only passage between the chambers will be through these peltiers, as they are the primary components which create the temperature difference between these chambers. Here I am cutting the holes for the peltiers on plastic notebook covers, along with some dents for the cables. I'm also gonna cut the same hole on the insulation material, which is just a styrofoam. It's generally better to align everything and plan where they are going to land before gluing them on. In order to stick the peltiers on the heatsinks, you should not use just any glue. Thermal compound is the best for this job, as it ensures maximum heat transfer and thus avoids any heat loss on the surface. Thermal compound is an important thing that is used mostly on computer processors. These two fans you see are the most powerful ones that I have, and I will use them to circulate the cold air to the room. Here I have completed all the structure. Now let me explain how I put this sandwich together. First, you apply some thermal compound on the peltier, and you push this peltier onto the cooler with your hand. Then you should apply thermal compounds to the other side too. After you can create a sandwich between two coolers by squeezing the coolers together. Yet this should stay tight. There should be no gap, I mean. For this I have used some hot glue. The reason of this is that thermal compound doesn't have any thickness. With hot glue, you can both squeeze and stick these together. Also, for the sandwich in the middle, hot glue was not enough, so I have used a zip tie for extra security. In the end, I have also hot glued the barrier between the chambers, avoiding any heat or air transfer. So, I have completed all the mechanical build of my homemade air conditioner. Also, the electronic is complete. I have covered the hot chamber with this styrofoam. The good thing about this insulation material is that it also has a reflective coating that avoids the radiation from outside. But of course, the main purpose of the styrofoam is to avoid heat to leak from the hot chamber. The heat is desired to escape only from the evacuation pipe, because we need to cool the room with this AC in the end. However, no insulation is required for the cold chamber. We already want the cool air to escape the cool chamber and cool the room. Therefore, there are two fans on the cold chamber increasing this cold air circulation. In addition to that, I have placed these heat sinks in a parallel alignment to allow faster airflow in the cold chamber. So I have made the power cable of the evacuation fan removable. Therefore, I can remove the cover of this box in order to fix anything or look at anything. Let's now give it a run to see it actually works or how much it actually cools the room. I will power the Peltiers with this power supply. This is normally a power supply for LEDs, but it can be used for Peltiers in my case, because it provides 36 watts, which is pretty good. And the Peltiers does not require a constant voltage, so I can use a constant current adapter like this one. On the other hand, the fans require a constant voltage of 12 volts, so I can't use this adapter for the fans. Therefore, I will use my desktop adjustable power supply to supply a constant 12 volts for all of the fans connected in parallel. As you can see, I have started the fans and powered the Peltiers. You can see how much power Peltiers use from this little spark. This constant current adapter which I'm using doesn't allow the maximum capacity power for the Peltiers, so I am planning to get a better one in the future. It is actually pretty useful for me being able to screw and unscrew this sink siphon pipe that I'm using. It makes things easier. Here I'm conducting a test for my device. As you can see, I have insulated the evacuation pipe too. I don't want to dig a hole on the wall of my house yet. I know this isn't very efficient, but I just want to feel the cold air coming out of this air conditioner. And here I'm making a temperature measurement for the homemade air conditioner. It's not very efficient actually, it only makes a difference of a couple degrees centigrade. It's not very efficient, but it was really great to experiment with these thermoelectric compounds and learn about the thermoelectric effect. If you want to see various fun to build electronic, mechanic or robotic projects, subscribe to my channel.